Hello, my name is Zishan. You're welcome to Zishan classes. Today, we're going to look into another problem from kinematics. There is a particle of mass m which is moving in a plane p due to a force f, the magnitude of which is constant, but the vector rotates with a constant angular velocity, omega. Now, there are a couple of things that we need to find. We need to find the velocity of this particle as a function of time and the distance covered by the particle between two successive stops and the mean velocity over this time. Now, this is the particle which is moving in this plane, and there's a force acting on it. Let us name that F. Now we see that this force has a constant magnitude, but it rotates with an angular velocity, which means that it is going to take the particle along this blue circle that we have drawn. You will find it moving here to a new location on the circle here, then a new location here, and you will find that the force F is always acting at a tangent to this circle. This way. Now, let us catch the particle somewhere here. The force acting on it is directed this way right now. And let us break this force into its components this way and this way. If this angle is equal to theta, this component will be equal to F cos theta, and this one will be equal to F sine theta. Also, let us assume that this direction is the x direction and this one is the y direction. Also, let us assume that the velocities, the components of velocity of this particle here are given by Vx, and let us say that the component in the y direction is given by Vy. We should also know that the angle theta can be written as omega into t, where omega is the angular velocity of rotation of the force F, and t is the time taken for the particle to reach this location, the location we have caught the particle on. We will write the equations of this of the motion of this particle along the x direction. So we have the force in the x direction, F cos theta, is equal to m times a acceleration in the x direction, which can also be written as dvx divided by dt. This implies that F cos of omega t is equal to m dvx by dt, and this gives us dvx is equal to f by m cos omega t dt. We will now integrate these two sides. For the velocity, the limits are going to be v0 to vx, and for time, we are going to take the limits as 0 to t. This will give us the value of vx, which will come out to be f sine omega t divided by m omega. We'll keep this with us. Similarly, we're going to write the equation along the y direction. F sine omega t, the force in the y direction, is equal to m times dvy divided by dt. This will give us dvy is equal to f by m sine omega t dt. Again, we will integrate both the sides from 0 to Vy on the left side and from 0 to t for the right side. This will give us Vy is equal to f by m omega into 1 minus cos omega t. We'll name this 2. Now, obviously, velocity v is equal to root over vx square plus vy square. This will give us root over vx from the first equation plus f by m omega 1 minus cos omega t whole square from the second equation. This will give us the value of v, which comes out to be 2f by m omega sine omega t. So we have got the value of velocity v as a function of time, which is the answer for the first part of the question. Now we will get to the second part of the problem. Looking at the equation of velocity, we can easily see that velocity assumes the value 0 at wt by 2 equals to 0 or at wt by 2 equals to pi. Wt by 2 equals to 0 is the point where we started, where the particle started at t equal to 0. Also, at t equal to 2 pi by omega, we get that this particle returns to its original location, and again the velocity has become 0. Now, looking at this part of the problem, two successive stops, they mean the points at which the velocity becomes 0. And we have already got those points where the velocity becomes 0. It starts from here, goes around, and comes back to the original location, and the velocity becomes 0. Broadly, they want us to find the distance traveled along this circle, the circumference of this circle. We know that S can be calculated using the formula VDT from time equals to 0 to a time equal to 2 pi by omega equal to 2f by m omega sine omega t divided by 2 from 0 to 2 pi by omega dt. This gives us S is equal to 8f by m omega square. Now we will also talk about the mean velocity during this time. The mean velocity can be calculated using this formula, integration v dt divided by integration dt. We already know from 0 to 2 pi by omega, from 0 to 2 pi by omega. This comes out to be 8f divided by m omega square, and this comes out to be 2 pi by omega, which can be reduced to 4f divided by pi m omega. So we have also got the value of mean velocity, the distance traveled, and the velocity as a function of time. These were the three things that we had to find, and we have already got it. And the only trick to the problem is to understand that this particle is going to go in a circle. Another thing to the problem is that the velocity is going to become zero every time it passes through this point, So this was it as far as this problem is concerned. There is nothing else to it. Let us see. I'll meet you in the next video. You have a good day. Bye.